Here's problem number 25 from section 8.2. We're asked, is this in a particular intermediate form? And if so, can we use L'Hopital's rule to solve it? When we look at this particular problem, as x gets closer and closer to 0, then this gets closer and closer to infinity. So 1 plus infinity so we have infinity in this part, we got a 0 there, so we get essentially indeterminate in the form infinity plus 0. So how do we solve this problem? How do we solve the problem of x approaching 0 from the positive side of 1 plus 1 over x to the x? Well, let's do some side work. And let's take a look at the natural log of 1 plus 1 over x to the x. Of course, we can bring the x down, and we get the natural log of 1 plus 1 over x. And if I try to take the limit of that, okay, as x approaches 0, of x times the natural log of 1 plus 1 over x, what we see is that this is going to 0, and then as x goes to 0, this is going to infinity, so natural log is going to, so this is indeterminate in the form of 0 times infinity. So I can rewrite this as the natural log of 1 over 1 natural log of 1 plus 1 over x divided by 1 over x. Now this is going to infinity, and this is also going to infinity, so it's indeterminate in the form of infinity over infinity, which means we can apply L'Hopital's rule to it. If we apply L'Hopital's rule to this, we're going to get 1 over 1 plus 1 over x times the derivative of this, which is negative x to the negative 2, and that's all over negative x to the negative 2. Those two cancel, which means we're now taking the limit as x approaches 0 of 1 over 1 plus 1 over x. So as x approaches 0, this thing approaches infinity. As this thing approaches infinity, this whole bottom approaches infinity, which means this whole thing is approaching 0. Or another way to look at it would be the limit as x approaches 0 of 1 over x plus 1 over x. That's finding a common denominator for the denominator for that, which is equivalent to the limit as x approaches 0 of x over x plus 1, and that clearly goes to 1. I need a second here. Oh, sorry. That's what happens if it goes to infinity. This is 0 over 1, which is equal to 0. Okay, so if that's the case, then we know that this is equal to the e of that 0. The natural log is taken of it, and to undo the natural log, we put that answer to the power of e. And of course, e to the 0 power is 1. Alright, there's number 25.